So boys and girls, in this video we are going to continue with the second part of the main concept in circular motion. So in previous video we talked about the centripetal acceleration, whereby we find out that for object that move in a circular path doing circular motion, it will always experience centripetal acceleration towards the center of the circle. Okay, so it will always have a centripetal acceleration towards the center of the circle, whereby the direction is always towards the center, perpendicular to the direction of linear velocity. So in this video we are going to continue with the concept. So we understood that according to Newton's second law that we already learned in topic 4, when the net force that acting on an object is not equal to 0, the object will accelerate according to Newton's second law that we already learned before, and the direction of acceleration is same as the direction of net force. The net force here, normally we write it as summation forces lah. So we are going to apply Newton's second law into object that doing circular motion. So for an object that move in a circle, we know that the object experience centripetal acceleration AC, right? You can see it obviously from the video. When object move in circle, it experience centripetal acceleration towards the center of the circle. So it means that if the object is accelerate towards the center of the circle, it means that there must be a net force which causes this centripetal acceleration. So this non-zero net force is always same direction as our acceleration, so it will always directed towards the center of the circle. So we give it a special name, we call it as centripetal force, FC. So for any object that move in a circle, there must be a net force. There must be a net force that always directed towards the center of the circle, so that it will causes a centripetal acceleration and enable for the object to perform circular motion. So what is the formula to calculate centripetal force? So we can apply Newton's second law to circular motion. So the net force or the summation of force equal to MA. So the summation of force here for object that doing circular motion, we give it a special name, we call centripetal force, because the direction is always towards the center of the circle. So FC, so the centripetal force F subscript C equal to M mass multiplied the centripetal acceleration. So from the previous video, we already learned the equation to calculate centripetal acceleration is V squared over R. So we put it into the equations. Then here comes the equation to calculate the centripetal force in a circular motion. So FC will be mv squared over R. Then we know that V is R omega. So put it in. So M, V is R omega. So squared both over R. So one of the R being cancelled. So we will get this one, mr omega squared. So this is the another equations we can use to calculate centripetal force in circular motion. And then we might also have V equal to R omega. So R is V over omega. So we put it in. So R is V over omega. So multiply omega squared. So one of the omega is being cancelled. So we have mv omega. So this is the another equation to calculate the centripetal force. So we have 3 equations to calculate centripetal force. Which one you are going to use, it depends on the information given in a problem that we want to solve. Okay, but what I would like to stress on here is, you have to bear in mind, the centripetal force actually is referred to net force that enable the object to perform circular motion. So centripetal force is not a new kind of forces. It's not a force, it's not a kind of forces like tension, weight. No, it's not a new kind of forces. Actually, centripetal force is referred to the net force that act on an object that doing circular motion. So any force or any component of forces that act along the radius, whether it's towards or away from the center of the circle, it can act as the centripetal force that causes the acceleration in a circular motion. For example, I attach a ball at the end of a string and then I swing it in a horizontal circle, so the ball is doing circular motion. So what is the force that supply the centripetal force for this case? So if I identify the force that act on this ball, it will have weight downwards, and along the string have tension. So this is the center of the circle. So you will find out that the tension is point towards the center. So the tension will be our centripetal force. The tension will act as centripetal force for these situations, whereby is equal to mv squared over r. Clear? Okay. We might consider this one. For example, we have a car round the horizontal round curve. Okay, dia lalu satu selekor tajam yang bulat macam ni. So this is the center of the circle. So as the car round the curve, it's doing circular motion. So for this car, we have weight downward because the car have mass, and then is moving or is in contact. The tire of the car is in contact with the surface. So perpendicular from the surface of the road, we have the normal reaction force. And then, so normally the road surface is rough. So there is a friction between the tire of the car and the road. So this is the friction, static frictions of the car. So we will find out that for this situation, the static frictions is the force that point towards the center. See, the direction of the frictions is pointing towards the center of the circle. So for these cases, for a car that round the curve, the static friction force will be the centripetal force equal to mv squared over r. Okay, so we might also have conical pendulum. For example, this one, we attach a ball to a string, and then we drag it at certain angle, and then the ball is performing horizontal circular motion. Okay, so for this ball, we will find out that this ball have weight downward, and then along the string we have tension, and this tension is acting at an angle theta. So that angle theta will be here. Okay, z, using the mathematics. So the angle theta here will equivalent to here. So this tension, when we resolve the tension, we will find out that we have the horizontal component of the tension is pointing to the center of the circle, pointing towards the center of the circle. So the horizontal component of the tension, Tx, will be our centripetal force for these situations. Okay, same go for this one. If we have a car that round the loop. Okay, so when the car is at the top of the loop, is doing circular motion. So for this car, its contact with the surface of the loop, it have normal force. Besides that, this car have weight W. So we can find out that the both weight and the normal force is pointing towards the center of the circle. This is the center of the circle. So we are going to, so it means that the normal force of the car and plus with the weight of the car, both of them is pointing towards the center of the circle. So they are acting as centripetal force. They are contribute to the net force that enable the car to accelerate in a circular motion. Okay, so this is what I mean by any force or component forces that act along the radius that point towards the center. It will act as centripetal force. So there are too many situations of object that perform circular motion, class. There are too many situations in daily life whereby the object is doing circular motion. So how we are going to solve the questions? So we suggest you a problem solving strategy whereby in order for you to apply for any situations in uniform circular motion. So because we need to identify what kind of forces that act as our centripetal force in order for the object to perform circular motion. So first thing, when we want to solve any problem that related to uniform circular motion, we are going to draw the free body diagram first, showing all the forces that act on the object that perform uniform circular motion. Then we will choose an axis, and we always set the radius as one of the axis lah. So radius of the circle will be one of our axis lah. Then if there is any forces that act at a particular angle, then we need to resolve the forces. After that, we are going to identify the forces or their component which is point towards or away from the center of the circle. These force or their component of forces, we are going to equating it with the centripetal force, because these component of forces that point towards the center, like this one, the forces that point towards the center, that one will be our centripetal force. So basically we have two types of uniform circular motion. We might have horizontal circle or vertical circle. So for horizontal circle, our radius is horizontal line, so our component forces of x-axis will equal to the centripetal force. The component y will equal to 0. The component y will always balance. But for vertical circle, our component x will in equilibrium, but the forces along component y will equal to centripetal force, Okay, so class, we are going to use this problem solving strategy throughout the tutorial for any situations given, so that we will solve the questions to find maybe the mass of the object, the velocity of the object, or the forces of the object for an object that undergo uniform circular motion. Okay, so this is the concept we have in uniform circular motion. And then boys and girls, saya dah summarize and kumpulkan semua konsep-konsep penting untuk topik circular motion dalam 2 pages macam ni. So anda boleh dapatkan dia ataupun download dalam bahan tutorial minggu lepas yang teacher muat naik dalam Google Classroom. Ataupun anda boleh download daripada grup Telegram kita.